Our story begins about 4.54 billion years ago. Imagine a vast cloud of gas and dust, remnants of a supernova. Gravity began to draw this material together, forming the infant Earth. Volcanoes erupted, spewing lava and gases into the chaotic atmosphere. The Earth was a cauldron of fire and fury, a hostile environment. Yet within this maelstrom, the seeds of our planet's destiny were being sown. Asteroids and comets rained down on the young Earth. These impacts delivered water and other volatile compounds. Through the violence and chaos, Earth began its journey. From a swirling cloud of dust to a molten sphere, our planet was taking shape. As the bombardment from space subsided, Earth began to cool. The molten surface radiated heat away, forming its crust. Volcanoes still erupted, releasing gases to form Earth's early atmosphere. The cooling allowed for the formation of liquid water. Torrential rains fell, forming the first oceans. These early oceans were hot, acidic, and bombarded by ultraviolet radiation. Yet within these waters, the miracle of life would soon begin. The stage was set for the emergence of life. The emergence of life from the non-living is one of the most profound mysteries in science. About 3.5 to 3.7 billion years ago, a remarkable transformation occurred. The basic ingredients of life swirled and interacted in the primordial soup. Energized by lightning, volcanic heat, and the sun's ultraviolet radiation, these elements formed complex organic molecules. Over millions of years, these molecules formed bonds, broke apart, and recombined. A molecule acquired the ability to replicate itself, marking a fundamental turning point. This self-replicating molecule was the precursor to all life on Earth. The exact process remains one of the greatest unsolved puzzles in science. One prominent hypothesis, the RNA world hypothesis, suggests that RNA was the central molecule in early life. RNA can store genetic information and catalyze chemical reactions. Early life forms may have relied solely on RNA. Over time, DNA evolved from RNA, taking over genetic storage. Proteins assumed the primary role of catalyzing biochemical reactions. Ribozymes are RNA molecules that catalyze reactions, support this hypothesis. The RNA world hypothesis offers a compelling explanation for the emergence of life. Unlocking the secrets of the RNA world could provide crucial insights into the origins of life. The metabolism first hypothesis proposes that life began with a self-sustaining set of chemical reactions. Life arose from interconnected chemical cycles forming a primitive metabolism. These cycles produced the building blocks of life. Imagine a network of chemical reactions, each step feeding into the next. These cycles could have evolved over time, giving rise to complex metabolic pathways. The emergence of self-replicating molecules like RNA occurred within this metabolic network. Hydrothermal vents and volcanic hot springs support this hypothesis. These environments create chemical gradients that could have driven early metabolic reactions. The last universal common ancestor, or LUCA, represents the root of the tree of life on Earth. LUCA lived around 4.2 billion years ago. Every living organism can trace its lineage back to this single-celled progenitor. LUCA likely had a cell membrane, genetic material, and a complex metabolism. Scientists infer LUCA's existence by studying shared characteristics of all living organisms. Comparing genetic sequences and biochemical processes reveals a core set of genes and proteins. These shared features point to a common ancestor. LUCA's existence speaks to the interconnectedness of all living things. For billions of years after LUCA, life on Earth consisted solely of single-celled organisms. These microscopic pioneers laid the foundation for all subsequent life. They transformed the atmosphere and shaped the oceans. The evolution of photosynthesis allowed organisms to harness sunlight for food. Photosynthesis released oxygen, transforming Earth's atmosphere. Oxygen-breathing organisms thrived, setting the stage for complex life forms. Competition, predation, and symbiotic relationships shaped early life. Single-celled organisms created a dynamic and ever-changing biosphere. LUCA's origins remain shrouded in mystery. It may have evolved from a simpler, self-replicating molecule like RNA. As this molecule replicated and mutated, it developed new abilities. Over time, advantageous traits spread, leading to a more complex organism. Another possibility is that LUCA emerged from interacting molecules within a simple membrane. These protocells evolved into more complex entities, giving rise to LUCA. LUCA's appearance marked the transition to complex cellular life. Its legacy is encoded in the DNA of every living organism. For billions of years, life on Earth was confined to the oceans. About 541 million years ago, the Cambrian Explosion occurred. Life erupted in a dazzling array of forms. Animals with hard shells, eyes, and appendages appeared. Rising oxygen levels and the evolution of predation drove diversification. The Cambrian Explosion established the basic body plans of most major animal groups. It was a time of incredible creativity and innovation. The legacy of the Cambrian Explosion is seen in the diversity of animals today. For billions of years, the land was barren and inhospitable. Plants evolved the ability to survive out of water. About 500 million years ago, the first land plants emerged. These early plants were simple, non-vascular plants like mosses. They clung to moist environments near water sources. As plants spread inland, they transformed the landscape. Fungi and insects followed, forming symbiotic relationships. The colonization of land led to the rich tapestry of terrestrial ecosystems we see today. As the Paleozoic era ended, reptiles were poised to inherit the Earth. The Mesozoic era, the age of reptiles, saw dinosaurs rise to dominance. Dinosaurs evolved a stunning array of forms, sizes, and adaptations. Some were ferocious predators, while others were herbivores. They inhabited various environments, leaving footprints in the fossil record. The reign of the dinosaurs was a time of dramatic change and evolution. Continents shifted, climates fluctuated, and new species evolved. Dinosaurs thrived, becoming one of the most successful groups of animals in Earth's history. The reign of the dinosaurs, though long and prosperous, was not destined to last forever. About 66 million years ago, a cataclysmic event brought the Mesozoic era to a close, wiping out an estimated 76% of all plant and animal species on Earth, including the dinosaurs. The culprit, a massive asteroid estimated to be about 6 miles wide, slammed into Earth near the Yucatan Peninsula in what is now Mexico. The impact, known as the Chicxulub impact, unleashed unimaginable devastation, triggering earthquakes, tsunamis, and wildfires that raged across the globe. The impact also released massive amounts of dust and debris into the atmosphere, blocking out the sun and causing a global cooling event that lasted for years. The KPG Extinction event, as it is known, marked a turning point in the history of life on Earth. It brought an end to the age of reptiles, paving the way for the rise of mammals and the eventual emergence of our own species. The extinction of the dinosaurs, though tragic, created an ecological vacuum that allowed other groups of organisms to flourish and diversify, reshaping the course of evolution. The aftermath of the KPG Extinction event was a time of profound change and opportunity. With the dinosaurs gone, the stage was set for a new cast of characters to take center stage. But the world they inherited was a far cry from the lush, vibrant planet that had existed before the impact. The skies were darkened by dust and debris, blocking out the sun and plunging the Earth into a prolonged period of cold and darkness. Plants withered and died, their photosynthetic engines starved of sunlight. The food chains that had sustained the dinosaurs collapsed, leaving a world struggling to recover. Yet, amid the devastation, life found a way. Deep underground, in burrows and crevices, small creatures had managed to survive the cataclysm. These survivors, mostly small mammals, reptiles and amphibians, possessed a unique set of adaptations that allowed them to weather the storm. They were small, with low metabolic rates, enabling them to survive on limited food supplies. Many were nocturnal, avoiding the harsh conditions on the surface, and they were adaptable, able to exploit a wide range of food sources and habitats. As the dust settled and the sun broke through the gloom, the survivors of the KPG extinction event emerged into a changed world. The dinosaurs, once the undisputed rulers of the planet, were gone. The forests that had once teemed with giant reptiles were now silent, their canopies replaced by ferns and other fast-growing plants. The extinction of the dinosaurs had created an ecological vacuum, a void that was quickly filled by the surviving groups of organisms. Mammals in particular were poised to take advantage of this opportunity. They were warm-blooded, allowing them to maintain a constant body temperature even in fluctuating environments. They had evolved a diverse range of teeth, enabling them to exploit a wider variety of food sources, and they gave birth to live young, which they nurtured with milk, increasing their offspring's chances of survival. These adaptations, once overshadowed by the dominance of the dinosaurs, now gave mammals a distinct advantage in the post-extinction world. They spread rapidly across the globe, diversifying into a dazzling array of forms, from tiny shrews to giant whales. The Cenozoic era, which began 66 million years ago and continues to this day, is often called the Age of Mammals. During this time, mammals underwent a remarkable radiation, evolving into a staggering array of forms to fill the ecological niches left vacant by the dinosaurs. In the oceans, whales and dolphins evolved from land-dwelling mammals, their limbs transforming into fins and their bodies adapting to a life in the water. Bats took to the skies, developing wings from their elongated fingers and mastering the art of echolocation to navigate and hunt in the darkness. On land, mammals evolved a stunning variety of forms and adaptations. Grazing animals, like horses and deer, developed long legs and complex digestive systems to extract nutrients from tough plant matter. Predators, like lions and tigers, honed their senses and hunting skills to bring down prey. Primates, the group of mammals that includes monkeys, apes and humans, also underwent significant diversification during the Cenozoic era. They developed grasping hands and feet, binocular vision and large brains, adaptations that allowed them to thrive in the complex environments of the forests. Among the many lineages of mammals that flourished during the Cenozoic era, one group would eventually give rise to our own species. Primates, with their grasping hands, keen eyesight and large brains, set the stage for human evolution. The earliest primates were small tree-dwelling creatures in Africa and Asia. Over millions of years, they evolved to thrive in trees. Their grasping hands and feet enabled agile movement through trees. Binocular vision provided depth perception for leaping between branches. Large brains allowed them to learn and use tools. As climates changed, some primates adapted to life on the ground. Early hominids faced new challenges in the grasslands. This transition drove evolutionary changes in hominids. Bipedalism freed hands for carrying tools and food. Larger brains and social structures enabled cooperation. This set the stage for Homo sapiens to reshape the world. As the African savannas stretched out beneath a changing sky, a remarkable chapter in Earth's epic saga was unfolding. From ground-dwelling hominids, Homo sapiens emerged. We carry the legacy of billions of years of evolution. Our ancestors were curious, creative, and connected. They fashioned tools, harnessed fire, and created art. Language allowed them to share knowledge and tell stories. Homo sapiens marked a turning point in Earth's history. We shaped our environment to suit our needs. Our journey took us to every corner of the globe. Our story is not one of linear progress. Human evolution is marked by brilliance and brutality. We have the capacity for both creation and destruction. From our humble beginnings in Africa, humans spread across the globe, adapting to a dazzling array of environments and developing a rich tapestry of cultures and languages. We built cities, established trade routes, and created art, music, and literature that reflected our hopes, fears, and dreams. We also waged wars, exploited resources, and caused widespread environmental damage. Our capacity for innovation and progress has often come at a cost, a reminder that our actions have consequences for both ourselves and the planet we call home. As we stand at the cusp of an uncertain future, it is imperative that we remember our place in the grand scheme of things. We are not separate from nature, but a part of it, interconnected with all living things through the intricate web of life that has been woven over billions of years. The epic journey of Earth's evolution is far from over. Our planet continues to change and evolve, shaped by both natural forces and human actions. The choices we make today will determine the course of our future and the legacy we leave for generations to come. Let us strive to be worthy inheritors of this extraordinary planet, using our intelligence, compassion, and creativity to create a future where all life can thrive. For we are not just the product of billions of years of evolution, we are the custodians of its future. Thank you for watching. Please subscribe to support our channel. Peace and love to all.